Hello, Mr. Burgos, and today we're going to be reading Chapter 1, What is Static Electricity, from our Interactive Science Notebook. And if you turn to page 394, it's where it starts. And notice, before I even start reading, one thing I like to do as a reader is to get myself kind of ready. I know this is nonfiction, and so if it's nonfiction, usually the author is going to give me some different text features to kind of get me ready and kind of help me understand what's going on. And notice they have, a picture, looks like some electric wires. There's some, it looks like almost like lightning going across between them. There's this picture of balloons over here with some plus signs and negative signs. Okay, that might be important as well. There are, this guiding question in the beginning, what is static electricity? So it's let me know this chapter or unit is telling me about static electricity. I also have a subheading. So I know this page is talking about static electricity. And it also has a key vocabulary term that's highlighted. And if it's highlighted, typically in the back, there's definitions. And in our books, we have like vocabulary cards you can look at to find the definition of it. Okay, so that kind of gets me ready. The cool thing about the science book too is it also has some experiments you could do. And this one you could probably do at home. So if you want to do that to kind of get your brain kind of thinking about maybe what static electricity is, you can go ahead and do that. But we're going to start on page 395. So if you can join me, it says static electricity. Atoms are tiny building blocks that make up all matter. Atoms themselves are made up of smaller particles. Some of these particles have an electric charge. Electric charge is a property of matter that can be described as positive or negative. Some particles and atoms have positive charge, plus sign to show it. Some particles have a negative charge, and they have a minus sign to show that. Some particles have no charge. Most matter has the same number of positive particles as negative particles. Because the charge balance, the matter has no overall electric charge. It is neutral. Okay, so before I keep reading, I'm going to kind of, look back and make sure I understand this before I keep going. Okay, so they're talking about atoms, okay, that are really, really small particles. They're so small you can't even see them with your own eye. And inside them, they have positive and negative pieces, okay? It says as particles, okay? And some are negative and some are positive. But most of these atoms have the same number, so they might have 3 negative and 3 positive, so they stay neutral. Okay, let's keep reading. However, charged particles can move from one object to another. Negative particles often move between objects that are close together or touching. When the number of positive and negative particles in an object are not the same, the object is charged. A neutral object can gain negative particles and end up with a negative charge. A neutral object can also lose negative particles and end up with a positive charge. An excess of positive or negative charge in an object is called static electricity. Okay, so let me see if I understand this part. They're talking about an object, and here we have a picture, so maybe we can use this. We have our two balloons, okay? And each of these balloons has atoms inside. And if I look, this balloon looks like 3 positive and 2 negative. So maybe I'll write that, 3 positive and 2 negative. And this balloon has 1, 2, 3 negative and 2 positive. And as I'm looking at my definition of static electricity, it's when you have an excess or extra of one or the other. So if I have more negative than positive, it has static electricity because it says an excess of positive or negative charge in an object is called static electricity. So both of these, I guess, would have static electricity because they don't have the same number in each. They have an imbalance. And so for your post-it note, remember for each question you're going to need to write a post-it note. And I can help you with this one. It says, circle, don't do it, just point to it. Or tell me about the color. The balloon that is negatively charged. Okay, so let's look at our two balloons. Our pink balloon has 3 positive and 2 negative, so it has more positive. Our green balloon has 3 negative and 2 positive, so it's going to have a negative charge. So in this case, it's our green balloon because it has more negative atoms or particles than the pink balloon. Okay, so that's static electricity. If it has an imbalance, anything that has more of positive or more negative, it's going to has static charge. All right, so let's keep reading. So now if I look at the second page, it says how charged objects behave. Okay, and so we're talking about how they behave differently. And so I'll kind of start reading that. Charged objects behave in predictable ways. If two objects have opposite charge, they attract or pull together. towards each other. Maybe you've heard the term opposites attract, okay, and this kind of goes with that. So if I have a positive and a negative, so let's say this one is positive, this one is negative, they're going to come together, all right? They're going to move towards each other. That's what they're saying. Objects with the same charge repel, all right? So then if I have two positives, they're going to move away from each other. All right? They push away from each other. Have you ever noticed that your hair stands on end after you take off a wool cap? That happens because the cap rubs against your hair. When it does, negative charges move from your hair to the cap. The strands on your hair are left with a positive charge. The hair stands up as they try to push as far away from each other as possible. Oh, so that's kind of cool. So if you look at the picture down below, that's why your hair stands up, because that static electricity, atoms are being moved, the charge is being moved from, the cap from your hair. Okay, and so we have a question here. How can you tell that these balloons have the same charge? Well, what's happening to the balloons? How do you know they have the same charge? Well, if they have the same charge, they can move away from each other, right? Number 3, the boy has just taken off his wool hat. Write a caption that tells us what is causing his hair to stand up. So on your post-it note, explain why his hair is standing up. What's causing that? All right. You can pause it to do that, and then we'll go on to the next part. Now, this next section, again, I have a subheading. So this is about electric force, this whole section, electric force. So I'm going to read. The pull or push between two charged objects is called an electric force. Electric force gets stronger when the charged objects are close together. Electric force can also exist between charged objects and neutral objects. So again, I guess as long as there's an imbalance, so more positive or more negative. For this reason, electric force can move lightweight neutral objects or lift them into the air. If you rub a balloon against your hair and then place the balloon against the wall, the balloon will stick to the wall. Why does this happen? First, the balloon picks up negative particles from your hair. So my hair transfers more negative particles to the balloon, so it gets more. Okay, so it becomes more negative, and so if it has more negatives than positives, it has a static charge. Okay. Then the extra negative particles on the balloon push away some of the negative particles on the wall. The part of the wall close to the balloon is left with an excess of positive particles. These positive particles attract the negative particles on the balloon. Again, so let's say if we're going to have my wall here. Okay, my wall is going to have, more positive than negative is what they're saying. Okay, because the balloon picked up extra negative particles from our hair. Okay, and then the extra negative particles on the balloon push away some of the negative particles on the wall. Okay, the part of the wall close to the balloon is left with excess of positive particles. So the balloon's going to have, the wall's going to have more positive than negative. So if they're opposites, more positive to more negative, they're going to attract and stick together. Okay. The part of the wall close to the balloon is left with excess or extra of positive particles. These positive particles attract the negative particles of the balloon. An electric force holds the balloon against the wall until the balloon loses its charge. Okay. So if it doesn't stick, that means we go back to neutral, where you end up having the same number on both. Okay. So it says draw positive and negative symbols on the balloon to show its overall charge. So maybe do it on a post-it note and cover the balloon with your post-it note. How would you show that it has a negative charge? So would you need more minus signs or more plus signs? And number 5, a negatively charged balloon lifts paper scrap but gets pulled towards clothing. Why do you think the balloon responds differently to different objects? And that kind of goes back to our push-pull on this page over here. So you might want to look back on this section for number 5. Why would it pull against some things and push against others? So put that on your post-it note here. All right, we have 2 more pages to go for static electricity, so if you can join me. And you're always welcome to pause it as you do your post-it notes and replay it. And then effects of static electricity. You dash across a carpet and touch a metal doorknob. Oh, let me go back, sorry. So again, this subheading, effects of static electricity. So everything here is talking about how static electricity affects other things. You dash across a carpet and touch a metal doorknob. Ouch! A small zap of electricity startles you. Sure, this happened to everybody. During a thunderstorm, you see a big bolt of lightning flash across the sky. How are the small zap and the flash of lightning similar? Both result from movement of charged particles. Okay, those mean.
Mr. Burgos, can you please enter your lunch count in attendance?
Sorry about that. Okay. The word static means not moving. An electric charge can stay on an object for some time, but eventually the charge does move. The negative particle on an object with negative charge may move to another object. This movement of charged particles releases electrical energy. You feel the electrical energy when you get shocked, and you see its effect in lightning bolt. Small shocks. So it's a type of shocks here. Static electricity can build up on all types of objects. It can also build up on you. You can pick up negative particles when you drag your feet on the carpet. You become negatively charged when you reach a metal doorknob. The negative particles travel from you to the doorknob. You might even see a spark caused by the release of static electricity. So again, these positive and negative charges, are always moving. So let's say, you have, you're kind of balanced, you're neutral, but then when you rub your feet on the carpet, you start picking up some more negative. So now you're kind of a charged item, and as you touch something else, it's going to cause a reaction. And same thing with lightning. Lightning is a result of fast, powerful release of static electricity. In a cloud, water droplets rub against each other. The droplets become electrically charged. Negative charge build up near the bottom of the cloud. The static electric is released when a positive particle on the ground attracts the negative particles in the cloud. When the particles move, the electrical energy heats up the air and makes it glow as lightning. Lightning often strikes the tallest object in an area. For this reason, it's safer to avoid the high ground during a lightning storm. Okay, and so what causes the glow of lightning? Well, they say kind of right here, it glows as lightning often strikes the tallest. When the particles move, the electric energy heats up the air and makes it glow. Okay, so when these particles, and so let's say, we have the ground and we have cloud in the sky. So we have more negative up here, and the ground we have more positive. We have this charge that comes, and it creates that glow that goes between them because we have that imbalance. Okay, we have positive particles on the ground attract to the negative particles in the cloud, and they react together. All right. So in your own words, I guess on your post notes, kind of also do 9 and 10, and you're more than welcome on a post note to fill out any of this section that we can address in class and go over. But here's our first notes, and I guess also want you to kind of say for number 6, looking back on here, look at the picture, explain what might happen if the boy picked up negative particles while walking across the carpet. Well, kind of discussed that, but on the post-it note, kind of be ready to fill that in as well. All right, and that's chapter 1.